So for our next speaker is Mr. Alex Mayer, who's a health scientist working at the National Institute for Occupational Safety and Health. He's currently working on the National Firefighter Registry, the NFR, with a primary goal of understanding the link between cancer and the U.S. Fire Service. He graduated the Masters of Public Health and Epidemiology from the University of Cincinnati in 2016. Since joining NIOSH in 2017, Alex Mayer has focused primarily on research relating to the exposure of flame retardants and firefighter health and safety, resulting in over 15 publications. Please join me in welcoming my colleague, Alex Mayer, on the NFR.
Oh, perfect. Yeah, thanks, Alberto. So as Alberto mentioned, my name's Alex Mayer, and I work on the National Firefighter Registry team with Dr. Miriam Siegel, who gave the nice presentation yesterday. But today, I'm going to discuss the NIOSH studies looking at firefighter exposures, primarily to carcinogens, and this is over the past decade or so, work that's been done primarily with the Illinois Fire Service Institute, as far as the name back there. And we'll also talk about some current best practices to assess and minimize those exposures. So this is an exposure pathway, and it's a diagram that was put together by UL FSRI, and it shows the different ways that firefighters can be exposed. So if you look at inside the structure, let's see, does that work? Yeah, we see you can have gas, vapor, or particulate that can of combustion byproducts that can be exposed to the firefighter. However, when they're inside the structure, they're wearing their personal protective equipment and their SCBA. When they come outside the structure and they take off that gear, there is the potential for some cross-contamination, skin absorption, or inadvertent ingestion when they're taking off their gear. And as many folks talked about yesterday, IARC has classified firefighting as a Group 1 known carcinogen. So I'm not going to get into that today, but part of the reason why they made that designation is because of the types of exposures we see for firefighters occupationally. So one of the ones we see is the night shift work or sleep disruption, which we know is a Group 2A probable carcinogen. Then we also have the UV radiation and diesel exhaust, which we know are Group 1 known carcinogens. And then we have the products of combustion, where we have multiple carcinogens, and that's primarily what I'll focus on today. That includes things like polycyclic aromatic hydrocarbons and volatile organic compounds, including benzene. And then there's also some other materials that can be released during fires, specifically things that are in home furnishing products, and that can include things like flame retardants as well as PFAS. So today I'm going to talk about 4 larger studies that NIOSH has worked with, and I'm going to start with the controlled residential fires. And this was in collaboration with the Illinois Fire Service Institute and UL Fire Safety Research Institute, as well as Skidmore College. So these took place in 2015 and at the IFSI training facility. And IFSI actually built structures for us here, and they included modern home furnishings within the structure. And then we had firefighters respond to these controlled residential fires via coordinated attack. Firefighters were paired up by job assignment, and they used different tactics, namely a transitional attack where they hit the fire with water before they entered, and the interior attack. And for this study, we did some biological and environmental monitoring. So as far as the environmental monitoring, we did airborne exposures monitoring. We did personal air sampling on the firefighters themselves. So inside the structure, we found that benzene was at 40 parts per million, which is about 40 times over the short-term exposure limit from NIOSH. And this was during the active fire. With pHs in benzene, we found that they can exceed the STLs during overhaul period. And then we also found that flame retardants, including BDE-209 and triphenyl phosphate, were the highest reported in the literature to date. It is important to note that for the flame retardants, we took bulk samples of the modern home furnishings, and these flame retardants were included in the bulk samples. So that's why we see them aerosolized during the fire, and that's why we captured them in the airborne exposures. The good news is a lot of the BDEs have been phased out of production, so we are seeing a reduction overall in their use and in firefighters' bloods over the past 5 or 10 years. As far as outside the structure, we did find IDLH levels of hydrogen cyanide during outside ventilation, and this was some personal air sampling that we did. And we also found that particulate and VOCs were well above background in the fire ground. And as far as the other environmental sampling that we did, we looked at some PPE contamination. In this graph over here, we have contamination found on the turnout gear. This is pre-fire, this is after the first fire, and then after the second fire. And the top graph are the interior operations, so that's inside attack and inside search, followed by overhaul, and then the exterior operations. So as you can see, we see a significant increase from post first fire to post second fire, and for those folks that are inside the structure, we're seeing a lot more contamination being built up. We also laundered some of the hoods after fires, and we found that there was some residual flame retardant contamination on the hoods after laundering, and that was primarily the PBDs, the 209 that we mentioned earlier. Looking at the urinary samples, we have this set up looking at across over here the overhaul, and then inside the structure attack and search and rescue, and then outside ventilation. And as you can see, those inside the structure have much higher levels than those found, or those that were overhaul or outside ventilation. Additionally, we saw that transitional attack resulted in 36% lower levels of hydroxypyrene and 50% lower levels of hydroxyphenanthrene. We also took some urinary VOC metabolite samples post-fire. Now, we only did these for firefighters that were inside the structure, so that includes just fire attack and search and rescue. But we did see significant increases from pre to post-fire for 3 metabolites, including xylenes, toluene, and styrene. And firefighters in the fire attack position generally had higher post-fire concentrations compared to those assigned to search and rescue. The next year, we conducted some sampling looking at training fires, and this was in 2016. This was, again, working with IFSI at their facilities. They had a training structure that they put together, and inside the training structure, they had 3 different fuel loads that they included. Pallet and straw was one, oriented straw board, or OSB, was the second, and then we also had simulated smoke as the third one. We had students who responded to 1 fire a day during those responses, and instructors responded to 3 fires a day. And there was 1 day off in between for all participants. And this is pretty typical of what we see in training academies across the country. And again, for this study, we did the airborne or environmental monitoring as well as the biological monitoring. For the airborne exposures, we found that the wood-based fuels, Paladin or OSB, produced pHs, benzene, and aldehydes that were well above exposure limits. We also found that different types of OSB, depending on what you use for your fuel, can make a difference. One type that we titled the Bravo OSB generated air concentrations of PAHs and benzene on par with the fully furnished residential fires from the previous year. And we also found that personnel downwind can also be exposed to concentrations well above background levels. For this study, we also included benzene samples pre and post-fire. And the way these graphs are set up, we have it stratified by the fuel type that we use. So there's simulated smoke, Paladin straw, and then we have Alpha and Bravo OSB, the 2 different types of OSB. We have the instructors on the left, and then the firefighters or students on the right. And as you can see, simulated smoke, we really didn't see a difference from pre to post fire, which is expected because there isn't any benzene in the simulated smoke. And the pallet straw, we saw a little bit of an increase, about 100% increase from pre to post fire for the firefighters or students. When we get down to the alpha OSB, we saw over 100% increase from pre to post fire for the instructors and almost a 200% increase for the firefighters. And then for that Bravo OSB, we saw a 600% increase from pre to post fire, or a median increase of 18 parts per billion. And it is important to note that firefighters wore SCBA throughout the response here. So it does appear that they may be absorbing benzene dermally because they wouldn't be able to breathe it in during the fires. Similarly, we took VOC metabolites from urine samples in the training fire. And this one we found multiple metabolites that were well above, or that increased significantly from pre to post fire, including 2 metabolites of benzene, xylene, acrolein, and styrene. And these were especially high among the instructors. They responded to 3 fires a day. And in fact, their levels occasionally rose above the median general population level for smokers. And overall, you can see the majority of the samples, regardless of the fuel type, increased significantly from pre to post fire. We did not include simulated smoke in this because we didn't expect the results to be significant. The next study is the Mannequin study, or PPE study. And this was turn the lights down, nice. Right. For the Mannequin study, we had a question about how do repeated exposures and launderings or gross decon impact the protective properties of gear. So we took mannequins and dressed them in firefighter gear and repeatedly exposed them to fires inside this structure here 40 times, and laundered the gear 40 times over an entire summer. The fuel that we used inside here was a sofa, and then we dressed the mannequins on either side and loaded them in. They ignited the sofa, and then smoke effluent was funneled into the 2 sides. And we had 3 different stratifications for our PPE for this study. So we had a laundered hook and D, and hook and D is just a closure type that some of you might be familiar with. I can show it on the next slide. And then we also had laundered zipper, so that's the traditional zipper that you would see. And the third type was the on-scene decon, just for the zipper. Oh, and I should mention, we also dressed the mannequins in particulate blocking hoods, as well as knit hoods. And we found that the particulate blocking hoods, or particle blocking hoods, reduced pH contamination, reaching the neck by about 30% compared to the knit hoods. We also found, we took samples underneath the gear because we were trying to look at breakthrough, how much is going through the gear. And we found that median pH concentrations under the hook and D were about 1.5-fold higher than under the zipper jackets. Unfortunately, benzene was shown to readily break through turnout gear irrespective of the closure mechanism or the laundering status, whether it was laundered or on-scene decon. So the next year, we did the human subjects, and we used some of the gear, those 40 times that were exposed or laundered. We asked firefighters to wear that gear while they were responding to fires. We also had a separate group of firefighters wear brand new gear and try to see if there were any differences between the two. We also had firefighters wear new knit hoods, new particle blocking hoods, and 40 times laundered and exposed particle blocking hoods. And they responded to training fires with the sofa as the fuel in the same structure, that shipping container that I showed a couple slides ago. And again, this was similar to our first couple studies where we had researchers evaluate the penetration of contaminants through the gear, and we conducted exposure and biological monitoring. So for this study, we were really interested in what's being penetrated through the gear. And so we're specifically looking at the penetration of VOCs and naphthalene. So the good news is repeated exposure and laundering did not appear to impact the properties of gear against the airborne chemicals that we were measuring here. The bad news is that we did see significant breakthrough for benzene, toluene, and naphthalene, 3 of the chemicals that we were looking at, inside the turnout jackets. And we also, in particular, we saw very little attenuation or protection from benzene. So we had air sampling under the gear and then air sampling outside the gear. We only saw about a 10% reduction comparing the outside gear versus the inside gear. We also took exhaled breath for this sample or for this study, and the 3 groups we have it separated out by are the hoods, the new knit, the new blocking, and the laundered blocking. Unfortunately, benzene concentrations in breath after firefighting increased for all 3 turnout gear conditions that were included here, and it did not appear that the type of hood had any effect on the benzene in the breath post-fire. Again, similar to the training fire, these findings suggest that firefighters can be absorbed to benzene via the dermal route, and that's because they were wearing SCBA throughout the entire response. Unfortunately, we're still analyzing the urinary pH results. The lab got pretty backed up during COVID, so we just got those results back in, but we're hoping to publish that soon. And we also did some dermal exposure studies looking at neck skin after the fire. And so we had the same stratification as the last slide, where we had the new knit, new blocking, and the launder blocking. Additionally, we had a doffing method that we looked at, so that we had some firefighters remove their hood in the traditional way where they just take it off. And we had some other firefighters, we had researchers help them remove the hood. That way, they were trying to keep the soot or pH contamination off of the neck area. And when we did this, we found that, interestingly, the laundered blocking hoods were significantly lower results compared to the new knit hoods. And the overhead process was significantly better at reducing the neck contamination for pHs compared to the traditional. So just some overall effectiveness of the control interventions that we've talked about here today. And these are ones that I've highlighted throughout the presentation. But the first is the transitional attack. We saw that there was a 36 or 50% reduction in the urinary metabolites of some of the pHs that we see in fire. We found that remaining upwind of the fire resulted in about an 80% reduction in airborne pHs and benzene compared to being downwind. The overhead removal process that I just talked about saw about an 80% reduction in pHs on the neck. And the hazmat style removal of gloves, which I didn't talk about, but it's removing the gloves similar to how you would remove them for hazmat, reduces cross-contamination. Some other interventions that have come through this work with IFSI and UL over the past few years includes looking at the use of skin cleansing baby wipes. So we saw about a 54% reduction in pHs on the neck if the firefighter used a baby wipe immediately post-fire. We also found, and this is one that's led to the preliminary exposure reduction, but the gross decon using dish soap and scrubbing, we found about an 85% reduction in pHs on the surface of turnout gear. It appears that segregating contaminated gear from each other is one way to greatly reduce the off-gas exposure. And as I mentioned earlier, we did launder some of the hoods. We didn't have much success with removing flame retardants from those hoods, but we did see about a 76% reduction in the pHs. This is another study that Dr. Jeff Burgess did a couple years ago, and wanted to share this too because I thought it was relevant to the discussion here. Engineers who wore SCBA in the presence of smoke had about a 40% lower urinary pH metabolite concentrations compared to those that did not. And firefighters who implemented several interventions, including gross decon, segregation of contaminated gear, and skin cleaning and showering as soon as possible, had 36% lower urinary pH metabolite concentrations. So as I mentioned earlier, I do work on the National Firefighter Registry team, and a lot of this work over the past 10 years has really informed some of the work, why we're putting together the National Firefighter Registry. And we're hoping that it can help us address some of these questions. So we are seeing that these control interventions are reducing potential exposures or the absorption of some of these chemicals like PAHs and benzene, but we really don't know to what extent do these different control interventions and workplace practices reduce the risk of cancer long term. So that's why we're hoping to that everybody, when we're up and running, is able to join the NFR, and hopefully in 10 or 15 years, we can answer some of these questions about, cancer risk for volunteer firefighters, subspecialties, differences by demographic group or regional area, and I think identifying the rare forms of cancer among firefighters is also a really important one. And I think that's it. So I'm happy to answer any questions you may have. And yeah, I just wanted to thank Miami for having us here today.
For your breath analysis, how do you collect the breath? Is it Tedlar bags or is it steel tubes for condensates?
Yeah, it's a steel tube, and we use a biovac, so the firefighter blows through the biovac, and then we attach. It's a steel carbonate tube, I think, and we push that through and then analyze that.
You do headspace analysis, right?
What is it?
When you do the GCMS, it's
Yes.
headspace, right?
Yep. Correct.
Okay.
Yep. And sorry, I should mention it's really important to get those as soon as possible post-fire. We see that those levels greatly reduce even 20 or 30 minutes after the fire. So as soon as they get back and they after they take off their SCBA, they come over and we collect that breath sample immediately. Okay. That's a good question. Not that we have seen. We have looked at, we've had different ages, anywhere from 18 to 55, and we haven't seen a age be a factor to that, but it's certainly something to consider. Our sample sizes are relatively small. We usually have anywhere from 20 to 40 firefighters participating, so it's definitely something to consider. Yeah, so we usually use NIOSH methods when we're doing our air sampling or our any of our passive sampling as well, and then we work with NCH for most of our biological sampling. The active personal sampling? Yeah, so we use a NIOSH method, approved methods for that. So we use an active air, like for the PAHs, we use an active air sampling pump, and we have an OVS tube that's sent away and analyzed using the NIOSH method. Yeah. Yeah. Yeah, some of the turnout gear sampling, for instance, there aren't necessarily approved sampling, so we're just trying to do the best we can for some of that. Yep. Yeah, so that's part of the plan. Oh, sure. Yeah, no problem. So your question was, do state cancer registries, are we going to be working with them for the National Firefighter Registry? And the answer is yes. So we will be collecting all the information, personal identifiers that we will use later on to link with state cancer registries to get those to get those diagnoses from the states themselves. Yep. Mm-hmm. Right, and just to be clear, what you just said, it's voluntary. I assume this is your not the state cancer registry, but your firefighter cancer registry. I see. So each state has its own cancer registry. If you get cancer in that state, it's a reportable illness, so it's required for your physician to report that to the state. So that's where we'll be getting the data for this. So we will have, and we actually have a really nice video, maybe we could show you later, that kind of explains the process of how we're going to go about linking with these state cancer registries. But that's how we'll be conducting that. Yeah, that's, yeah. Right. Any other questions? Perfect. Oh, yep. They come to the cold zone and then, oh yeah, sorry. Yeah, so she was asking if where the firefighters take off their SCBA, if it's in the hot zone or the cold zone. So they travel. The fire was about 150 yards away from where they came downwind, or sorry, upwind, and took off their SCBA, and then that's where we had our data collection tent. We were collecting the air samples as well as collecting the exhaled breath. So it was typically, I think you asked time too, it's about 3 to 5 minutes for them to get over. Yep.
Just to follow up on that, when were they actually going on air? And when were they coming off air? You know, typically in firefighting, you put all your SCBA on and you stage in the warm zone. As soon as you walk into the houses, then you actually click on. For your experiments, was that how it was taking place?
Yes.
Or were they going on air in the cold zone and then walking into the hot zone?
So the question was, when did they go on air? And the answer is in the cold zone. So they were on that and then walked in. So it depends on the study. We had different protocols for the beginning, but before the fire was on, or before the fire was ignited, they were on air. Yep. So the question is, did we monitor the temperature inside the gear based on age of gear? Unfortunately, all the gear that we had was the same age. Now, we did look at the temperature inside during the 40 fires to see if it was changing after 40 repeated exposures and launderings over the summer, and we did not see a change over those 40 fires. All right, thanks a lot.